Jane and the Cleveland skull may be related to growth, and they may still both be juvenile T-Rex.
A large number of paleontologists looked at the remains and said this can't be a juvenile Tyrannosaurus rex.
The preservation is just superb.
Rare dinosaur fossils may be lost to science forever when they go up on auction in November.
Two of the best preserved dinosaur skeletons in the world are coming to the North Carolina Museum.
Scientists finally agree Rockford's dinosaur Jane is a bona fide T-Rex.
Definitely not an adult specimen.
Everything we thought we knew was wrong.
I think most people have pretty much come to the conclusion that it was a juvenile Tyrannosaurus.
These represent a completely different type of Tyrannosaur.
It's one of the most important fossils found in recent record.
For the past 120 years, Tyrannosaurus rex was believed to have reigned as the sole, undisputed apex predator of Maastrichtian North America. But this all began to change in 1942, when a fossil was uncovered that would go on to shake the dynasty of the Tyrant dinosaurs to its core. This single skull, and the subsequent fossils of similar-sized theropod dinosaurs, would spark one of the most intense debates in the entire history of paleontology. Did these animals represent younger specimens of the mighty Tyrannosaurus rex, or did they represent something much more intriguing? That being, a medium-sized theropod that would have coexisted with, and perhaps even competed with the king of the dinosaurs on its own turf. Coming from an ancient continent far to the east, and of a stock of Tyrannosaurs far more basal than those that would lead to the rise of T-Rex, this animal would challenge our very understanding of the entire family of Tyrannosaurs, and in doing so, make its name known across the whole world. And the name of this incredible animal was, of course, none other than Nanotyrannus, the Dwarf Tyrant. The story of this enigmatic dinosaur begins in the year 1942, when the curator of the Cleveland Museum of Natural History, David Dunkel, would unearth a skull in what is now the Hell Creek Formation, but was at the time considered to be a part of the Lance Formation. To this skull, paleontologist Charles Whitney Gilmore would assign the name Gorgosaurus lancensis in 1946, with lancensis being a reference to the Lance Formation which he believed the animal was from at the time of its discovery. Soon after its discovery, it was later transported to the previously mentioned Cleveland Museum of Natural History and would be subsequently nicknamed the Cleveland Skull. Since its initial description as a new species of Gorgosaurus, this animal would be described to many different dinosaur taxa until it was given its own name in 1988 by paleontologists Robert T. Bacher, Michael Williams, the at the time curator of the Cleveland Museum, and Philip J. Curry. The specific name, as previously mentioned, is a Latin word meaning of the lance, in reference to the Lance Formation that the animal was originally thought to be from, while the generic name is a combination of the Greek words nanos, meaning small, and tyrannos, meaning tyrant, ultimately leading to the scientific name Nanotyrannus lancensis. meaning small tyrant of the Lance Formation. However, this classification of Nanotyrannus as a distinct dinosaur was not a universally held opinion. In 1965, Soviet paleontologist Anatoly Konstantinovich Rozdestvensky would propose the idea of Nanotyrannus being a juvenile Tyrannosaurus rex even before it was given its generic name. However, this debate wouldn't start gaining prominence until 1999, when paleontologist Thomas D. Carr did an analysis on the specimen and determined it to have been immature, leading to numerous other paleontologists to begin to denounce Enlancensis as simply a young T-Rex. This position was seemingly backed up further when 2 years later, an incredibly important fossil was discovered in 2001. Discovered in the Upper Hell Creek Formation, a vastly more complete specimen, cataloged as BMRP 2002.4.1, otherwise known as Jane, was proposed to belong to the same species as the Cleveland skull, and given that this animal was so much more complete, it instigated a much larger debate into the true nature of the animal. Following the reveal of Jane to the public, a conference held at the Burpee Museum of Natural History took place in 2005 that further discussed the controversy behind whether or not Nanotyrannus was a valid species of dinosaur. Paleontologists who had previously proposed it to be a distinct species, including Michael Williams and Philip J. Curry, saw this at the time newly described specimen to be direct evidence that Nanotyrannus was, a matter of fact, a juvenile Tyrannosaurus rex. Despite this, paleontologist Peter Larson, who was also present at the conference, would proceed to justify the idea that Enlancensis was a separate species from the king of the dinosaurs. Along with this, he would also propose that the now dubious Stygivenator, which is thought to be a young T-Rex, is actually a juvenile specimen of Nanotyrannus. While a few paleontologists still held onto the belief that Nanotyrannus was a separate animal, the discovery of Jane essentially ended any seriously considered notions as to the validity of the Nanotyrannus genus. And, in the following decades, assertions that Nanotyrannus was indeed a separate genus would be subject to some of the highest scrutiny of any ideas in the entire field of paleontology. Nanotyrannus indeed became a topic of jest among many, and those who dared to speak about it as a separate genus were usually heavily ridiculed to such an extent that serious discussion and debate about Nanotyrannus as an independent genus was almost entirely impossible. This would remain the norm for a large portion of the next 2 decades leading up to the 2020s, and even further into the new decade, as a paper released by Longrich et al. In 2024 advocating for Nanotyrannus validity was still being met with heavy scrutiny among paleontologists and ridicule among the larger paleontological community. However, one incredible fossil discovered in 2006 was about to change everything for Nanotyrannus in the mid-2020s.
Actually, only 2 skulls exist, and they're partial skulls.
A rather special fossil was excavated from Montana by ranchers and commercial fossil hunters Mark Eatman, Chad O'Connor, and Clayton Phipps. They were uncovered on private property owned by the Severson and Murray ranching families. Although it was found in 2006, information about this revolutionary find wouldn't be announced until 2011. Upon this discovery, Phipps would go on to acquire the assistance of CK Preparations ran by preparator Chris Moreau and paleoartist Katie Bush. Upon their first inspection, they thought the 2 dinosaurs died while locked in combat. However, they came to the conclusion that they instead retained their position as a result of the burying process. At the dig site, Peter Larson and Robert T. Bacher labeled the fossils as those of both Triceratops and Nanotyrannus. However, given that the fossils were locked away on private property, it was thus impossible to truly find out if the preserved theropod specimen dubbed Bloody Mary was that of a juvenile T-Rex or indeed a highly controversial Nanotyrannus. Thankfully, in 2020, the fossil's ownership was transferred by the Montana Supreme Court to the landowners Lige Murray and Mary Ann. Murray and Ann subsequently agreed to sell off both specimens to a natural history museum based within the United States, that being the North Carolina Museum of Natural Sciences, where the incredible discovery was labeled as the dueling dinosaurs. Upon receiving the dueling dinosaurs fossils, the museum also constructed an additional lab that was designed to study, prepare, and officially display the specimens to the public, while work was being done on the fossils. 5 years later, in 2025, the museum's head of paleontology, Lindsay Zano, along with fellow paleontologist James Napoli, would perform intense scientific analyses that would have immense consequences and change our understanding of the legacy of Tyrant dinosaurs forever. In this paper, the dueling dinosaurs was finally given a formal description, and Bloody Mary was additionally given a new catalog number under NCSM 40,000. Initially, it was believed that Bloody Mary was 98% complete, but further preparation of the specimen found it to be 2% more complete than it was initially thought, making Bloody Mary one of the most complete theropods ever found in Hell Creek, being 100% complete with every single bone being accounted for. After the nearly 20-year history of the specimen, first discovered by private collectors and in private hands, to it eventually being lent to a museum where paleontologists can study this special specimen, it all came down to this then upcoming paper to end the nearly 30-year-long debate once and for all. And when it was finally published, the back and forth story of the Nanotyrannus debate had conclusively ended. It is indeed a valid and distinct genus. Much like some of the publications that came before it, this paper had similar arguments in support of its validity, such as the tooth count differences between Nanotyrannus and T-Rex, and the presence of a small foramen on the quadratojugal bone. Interestingly, unlike the Cleveland skull and Jane, this specimen preserved both of the forearms, and from this, paleontologists were able to see that Nanotyrannus' arms are much longer than those of even adult tyrannosaurs like Y-Rex, and with a much different bone morphology, even including a basal third finger that is almost entirely reduced in Tyrannosaurus rex. Alongside this, growth rings in one of Bloody Mary's bones found that the specimen was completely mature, estimated to be around 14 to 22 years of age at the time of death. This would end up being the final nail in the coffin to the idea of Nanotyrannus being a juvenile T-Rex. An adult animal of that size is simply not going to grow into the monster that would be Tyrannosaurus rex. However, the watershed discoveries don't stop here. Out of all the other Nanotyrannus specimens that have since been described, Jane is found to be the most distinct and separate of them all. Zano and Napoli therefore found Jane to actually be the holotype of a brand new species of Nanotyrannus, that being Nanotyrannus lithaeus, with the specific name referencing a river from Greco-Roman mythology named the Lethe, which is said to flow through the underworld. Although fitting to where Jane was found, in the Hell Creek Formation, the name is also meant to reference the fact that people who drank from this river would forget their past lives and be reincarnated as something else. Much like how Jane is no longer considered to be either Nanotyrannus lensensis or a young T-Rex individual. This description was one of the most unexpected twists of the new paper, and with it, Zano, Napoli, and colleagues have completely changed our understanding of Nanotyrannus and how T-Rex truly grew. In response to this bombshell of a publication, Tyrannosaur experts such as David Hone, Thomas Carr, and Steve Brusatte have accepted its validity. However, there are still some paleontologists like Holly Woodward Ballard who still urged caution about this paper, and Carr, along with Brusatte, objected the classification of N. lithaeus. Carr, regardless of his acceptance, still suggested the possibility that Nanotyrannus at the very least is a different species of Tyrannosaurus, that being T. lansensis. In the following years leading to the end of this debate, 3 additional Nanotyrannus specimens, specifically from N. lansensis, were also discovered, which were also believed to be young Rex specimens before the paper was published. These 3 specimens, 2 of which were discovered around the same time as Jane, are BMRP 2006.4.4, nicknamed Petey, KUVP 156375, nicknamed Laurel, which is the newest specimen discovered in 2016, and SWAU HRSO 8438, nicknamed Zuri. Also discovered in 2001, Zuri is strangely the only Nanotyrannus specimen that's not mentioned in the new paper. If Zuri is indeed a Nanotyrannus, it might be the first specimen for the genus to truly be recovered from the aforementioned Lance formation. Overall, Nanotyrannus has an extremely rich and controversial history in paleontology. Its discovery and its now official validation has completely changed our understanding of Tyrannosaur diversity in the latest Cretaceous of North America, showing us just how diverse the world of dinosaurs truly was at its end. In order to understand the differences between Nanotyrannus and Tyrannosaurus, the authors of the new paper, and other publications made prior to the end of the debate, had to thoroughly analyze the overall body proportions of both genera. Comparing Nanotyrannus to adult Rex specimens, there is a clear difference. Much like the larger Albertosaurian tyrannosaurids and the Asian Alioramini tribe, Nanotyrannus was also a lanky, medium-sized, fast-running animal, whereas Tyrannosaurus was larger, bulkier, and far more muscular, and it wasn't the kind of predator made to be a fast runner. So one question remains. Why did paleontologists think that Nanotyrannus was a juvenile T-Rex? This idea first came about because of the severe lack of young T-Rexes compared to the vast array of adults known. However, it is now known that there are real young Tyrannosaurus specimens, ones that showed a clear anatomical difference to specimens like Jane and Bloody Mary. Some of these real young Rexes include a 2 to 3-year-old specimen nicknamed Chomper, a 4-year-old nicknamed Baby Bob, a 16-year-old teenager nicknamed Rocky, one of the most complete young Rexes, and lastly, probably the most important and recent discovery, a well-preserved specimen found in 2022 nicknamed Teen Rex. Comparing these specimens to the ones assigned to Nanotyrannus, it is clear from the proportions that a lot of things seem off. The diagnostic differences can be seen when comparing their skulls, forearms, hind limbs, overall vertebral count, and not to mention the time it took for both genera to grow. The time it took for both tyrannosaurs to grow is vast, and the amount of changes a Nanotyrannus would have had to go through in order to become an adult T-Rex is extreme. For instance, the skull has many different traits compared to actual teenage Rexes, such as the presence of a small foramen on the quadrata jugal, which is one of the oldest arguments against Nanotyrannus being a young T-Rex, a difference with the lacrimal crests, such as the complete lack of a corneal process, the neurovascular channels around the snout are structurally different, the lack of serrations in the premaxillary teeth, and of course, the number of teeth in its jaws. Unlike T-Rex, which has a total of 12 to 13 teeth in its maxilla and 11 to 14 in its dentary, Nanotyrannus has a total of 14 to 15 in its maxilla and 17 in its dentary. Putting aside the skull, the forearms and hands are larger when compared to T-Rex specimens like Y-Rex. The hind limbs, especially the metatarsals and toes, were far more designed for a cursorial lifestyle, which T-Rex did not have. The vertebral count that makes up the backbone is also different. While Nanotyrannus has a total of 35 caudal vertebrae, T-Rex has a total of about 42. In short, Nanotyrannus would have had to change a ton of completely ossified anatomical traits in its bones, growing extra tail bones, and losing tooth counts in order to become an adult T-Rex as if it's a minor metamorphosis, which is not known in any living or extinct Archosaurian reptile. In fact, the skull traits of Nanotyrannus, especially with its premaxillary teeth, fall more in line with basal eutyrannosaurs like Utah's Moros and China's Zhangguanlong. Speaking of, much like other eutyrannosaurs, Nanotyrannus was also similar in size to them when fully grown, which is another attribute that differentiates it from T-Rex. Nanotyrannus lancensis, going off the Cleveland skull, was estimated to have reached a total body length of 5.2 meters or 17 feet and weighing around 450 kilograms or 1,000 pounds. Zano and Napoli's 2025 publication, going off of Bloody Mary this time, estimated a total mass of 703.8 kilograms or 1,551.5 pounds. This would make N. lancensis one of the smallest tyrannosauroids from the late Maastrichtian fossil record, and it was just about as big as some of the largest Paravian theropods that lived during the late Cretaceous overall, like Ostroraptor and Echilibator. As for the other species, Nanotyrannus lithaeus, the holotype Jane is estimated to have reached a maximum body length of 6.4 meters or 21 feet with a weight of 833.9 kilograms or 1,838.5 pounds at the time of death. However, Jane was still in the process of growing, so Enlithæus might have actually been larger once fully grown, with the authors suggesting a potential adult mass of approximately 1,500 kilograms or 3,300 pounds. This puts Enlithæus around the same weight and potentially the same length as New Jersey's Tryptosaurus, which is also 1,500 kilograms and was a 7.5 meter or 25 foot long theropod, making it larger than Nanotyrannus lancensis, but still smaller than T-Rex. Overall, the many diagnostic features of Nanotyrannus show a clear difference in growth and maximum body size. These traits are what allowed the taxon to be its own unique animal. However, there was one other thing that made the dwarf Tyrant different from the king of the dinosaurs, that being its new position in the Tyrannosaur family tree. Ever since the first fossil of this animal was unearthed, the family tree of Nanotyrannus has remained a mystery. As discussed previously, it was initially assigned as a species of Gorgosaurus. However, in 1988, it would be assigned as its own genus, that being, of course, Nanotyrannus. This was soon followed up by the synonymy debate with Tyrannosaurus rex, and for years, due to the genus being a synonym to Tyrannosaurus rex, the taxon was usually classified as a Tyrannosaurid. However, other authors over the decades, assuming that Nanotyrannus was a separate and valid genus, have attempted to place Nanotyrannus into different groups. Some of its most famous phylogenetic placements in the past, putting aside the typical Tyrannosaurian placement, include Nanotyrannus having been suggested to be a member of Albertosaurinae in 2016 by paleontologist Joshua Schmerge, making it closely related to the also lanky, thin-snouted, fast-running Tyrannosaurids Albertosaurus and the very Gorgosaurus to which it was originally assigned. Another taxonomic placement was the possibility of it being a Dryptosaurid, according to paleontologist Nick Longrich in 2024. Dryptosauridae is a group of non-tyrannosaurids that come from the ancient continent of Appalachia, containing the popular Dryptosaurus and potentially other close relatives that remain undescribed. He also proposed the possibility of Nanotyrannus even being a synonym to Dryptosaurus itself as well. This paper was, however, quite controversial at the time, unlike another paper that would be released the next year in 2025. According to this 2025 publication, the latter idea of Nanotyrannus being a Tyrannosauroid would hold up quite well, as Zano, Napoli, and colleagues suggested a similar phylogenetic position. The authors proposed a new family tree for Nanotyrannus respectively, aptly named as Nanotyrannidae. This makes Nanotyrannus a Eutyrannosaurian outside of Tyrannosauridae itself. Other resolved family members aside from Nanotyrannus in this group are split by two different analyses. The first analysis finds that the velociraptor-sized Moros intrepidus, a Tyrannosauroid from the Cenomanian of Utah, is a sister taxon to Nanotyrannus lithaeus, while the specimens assigned to Nanotyrannus lancensis are recovered in an unresolved clade. However, if this is indeed the case, it would seem to imply that N. lithaeus is not a Nanotyrannus at all, but rather a different genus, due to it no longer being a sister taxon to N. lancensis, but rather M. intrepidus. In the second analysis, Moros is found to be outside of this family tree. Both species of Nanotyrannus are recovered as sister species, and in place of Moros, Appalachiosaurus and Dryptosaurus are found to be basal to one another. This not only means that the southeastern Appalachiosaurus is unofficially in a specific family tree, but this analysis also shows that Nanotyrannus possibly evolved from a non-Tyrannosaurid Tyrannosauroid from the mysterious eastern continent of Appalachia, suggesting that after the ancient western interior seaway receded, basal tyrannosaurs crossed over into Lauramidia and coexisted with derived tyrannosaurs like T-Rex. However, more research and fossil discoveries of tyrannosaurs from the east coast need to be made in order to conclude this latter latter hypothesis. Additionally, there is a chance that Nanotyrannus could eventually end up being placed under the already named family Dryptosauridae, since the family that was named centuries prior to Nanotyrannidae and contains all of the same members with the exception of Appalachiosaurus unless suggested otherwise. This would, according to modern phylogenetic rules of classification, give Dryptosauridae priority. Overall, thanks to the new paper validating Nanotyrannus once and for all, the rich diversity of North American tyrannosaurs has greatly expanded, and the evolution of these incredible predators is now known to have not stopped even towards the bitter end of the age of the dinosaurs. These new findings also greatly rework our understanding of the life cycle for Tyrannosaurus rex itself, and hopefully this new find will help increase the interest of more special fossil findings in Appalachia. Thanks to the new publication by Zano and Napoli showcasing the conclusive validity of Nanotyrannus, we now know that the late Maastrichtian North American ecosystem was inhabited not by one or two, but 3 different species of Tyrannosaur. Interestingly, this amount of Tyrannosaur diversity can also be seen in the Nemegt Formation in Mongolia, which also has a total of 3 different Tyrannosaurids, those being Tarbosaurus and both species of the lanky Alioramus. Nanotyrannus has so far only been found in the Hell Creek Formation in what is now Wyoming and Montana. Considering how many specimens of the genus have been found, it's not impossible to believe that Nanotyrannus will eventually be uncovered in other late Maastrichtian aged formations too, expanding its current geographic range. As covered previously in our T-Rex video, the environment of late Maastrichtian Western North America would be surprisingly similar to environments much like the Floridian Everglades, which is dominated by marshes, wetlands, swamps, and floodplains, environments of which were supported by the remnants of the gigantic Western Interior Seaway. Many of these plants that lived during this time can also be seen today, which includes ferns, horsetails, early grasses, flowers, ginkgos, and conifers much like the modern sequoia, metasequoia, and taxodium. There are also completely extinct taxa like the conifer Podocarpoxylon, the extinct palm Sabellides, the fern Osmonda, and various other gymnosperms and angiosperms. Unlike its massive rival that was the apex predator of its continent, Nanotyrannus was a pursuit predator that occupied a medium-sized speedy predator niche. Both N. lencensis and N. lithaeus would rely on their speed more so than stealth and ambush. Considering that Tyrannosaurus rex was an ambush predator designed to hunt other giant dinosaurs of its size, they would have occasionally coexisted due to their different lifestyles and size of prey. With its lanky proportions and slightly longer arms, Nanotyrannus relied on its speed, its strong bite force, and arms for grasping and eventually taking down its prey. In order to successfully chase their prey down, since these animals had evolved to be pursuit predators, both species of Nanotyrannus have been estimated to run as fast as 35.8 and 32.7 miles per hour respectively, making them significantly faster than T-Rex, which is estimated to have had a top speed of only 11 miles per hour. In life, Nanotyrannus would have mostly hunted smaller game in its environment, such as the small ornithopod Thescelosaurus, various pachycephalosaurs of different sizes, ornithomimids, canignathed oviraptorosaurs, the alvarosaurid Triararchicus, the ceratopsian Leptoceratops, small dromaeosaurs and troodontids, the offspring of larger ceratopsids, hadrosaurs and tyrannosaurids, and other small animals which would have included large mammals, small crocodilians, the semi-aquatic Champsosaurus, and potentially even birds and pterosaurs like the newly named SpinoDragon, and an as of yet undescribed pteranodonted. Although this predator had many prey items to choose from, it still had its fair share of competition and many dangerous animals to avoid. Larger herbivores like Triceratops, Torosaurus, Ankylosaurus, Denversaurus, and Edmontosaurus would have been highly defensive if necessary to protect their young or themselves. Additionally, both Nanotyrannus lencensis and N. lithaeus would have not only competed against each other for food and territory, but they also needed to compete with large dromaeosaurids such as the enigmatic and potentially dubious Dakotaraptor, and of course, the massive Tyrannosaurus rex. which they would have occasionally fallen prey to if unaware of this ambush predator's presence. Smaller Nanotyrannus individuals also likely fell as prey to crocodilians and the rare occasion of marine reptiles that may have ventured into shallow waters or large bodies of freshwater like mosasaurs. All in all, Nanotyrannus plays an important role in the Hell Creek ecosystem, showing the diverse array of predators that occupied a medium-sized predator niche, bringing balance to the population of herbivores in its surrounding environment. While Nanotyrannus has not seen anywhere near the same number of appearances as its distant relative, it has still made a decent amount of appearances in media over the years since its discovery, primarily in the form of documentaries discussing its validity. With that said, its first appearance of any kind was actually in the novel series Quintaglio Ascension, making its first appearance in the 1992 book Farseer. The sequel, released in 1993 titled Fossil Hunter, states that they, the Quintaglio, a race of lizard people, are the direct descendants of Nanotyrannus. Transitioning into video games and other various media, its next appearance would be in the 2001 expansive Jurassic Park website, with many games and activities known as Jurassic Park Institute. In the Dinopedia section of the website, Nanotyrannus has its very own artwork and design created by Tim Bradley. However, around 2006, the website was unfortunately taken down and lost forever. Nanotyrannus' next appearance would be the following year in the fourth installment of the Carnivores franchise known as Carnivores Cityscape, as a boss within the first level, and is later seen as a common enemy and the second playable dinosaur in the game. In 2009, a line of toys created by Mattel referred to as Extractors has a speed-based kicking character from the Tyrannosaur clan named Quickfire, who is actually a Nanotyrannus. Upon buying the toy, he can be transported into an online computer game with the same name as the toy line Quickfire originates from. Its latest video game appearances are in the 2018 mobile app Jurassic World Play, following the release of Jurassic World Rebirth in 2025. Moving on to its more prominent appearances, Nanotyrannus has rather more of a spotlight in a great deal of documentaries. Its first possible appearance could be in the 1999 six-part BBC docuseries Walking with Dinosaurs in episode 6, Death of a Dynasty. In the beginning of the episode, we see a litter of animal carcasses of individuals who were unfortunate enough to have been killed in the sulfur gas. One carcass of which is a smaller tyrannosaur of indeterminate origin that has led many viewers to speculate as to whether or not it's simply a juvenile Tyrannosaurus or perhaps rather a Nanotyrannus. Walking with Dinosaurs aside, it made its first confirmed documentary appearance in the 2006 Discovery Channel short docu-film The Mystery Dinosaur, revolving around the excavation and controversy behind the recently discovered specimen Jane. Within its early days of being depicted in various forms of pop culture, Nanotyrannus was a rather obscure genus typically overshadowed by Tyrannosaurus rex. However, going into 2008, a certain History Channel documentary would release an episode to TV that would see the notoriety of this animal increase sky high. At the time, the History Channel would produce a documentary series known as Jurassic Fight Club, a TV show depicting hypothetical fights among prehistoric creatures and discussions as to who would win in each scenario. Out of all of its episodes, one in particular would become rather infamous, that being, of course, T-Rex Hunter. In T-Rex Hunter, two Tyrannosaur parents go out for a hunt and leave their offspring behind at their home. Moments later, we see a lone Nanotyrannus individual ambushing the offspring and begins to fight them, killing one of them and nearly bringing the other baby to its end. However, before this can happen, the mother Tyrannosaurus returns and brutally kills the intruder by crushing its spine and ripping its carcass apart to leave its corpse as a warning to other potential predators wandering in the area. Following the release of this episode, the question behind whether or not Nanotyrannus was its own distinct genus or simply a juvenile Tyrannosaurus rex would more fiercely enter into conversation amongst paleontologists and the broader paleontology community as a whole. The ensuing years of discussion would see it become perhaps the most controversial animal of all time. Following the eventful release of T-Rex Hunter in the year 2009, Nanotyrannus would be shown in the National Geographic documentary Dinosaurs Decoded, with its own CGI model and featured in its own segment where the debate is brought back up with paleontologist Jack Horner. 4 years later, an artwork for it made by Louis V. Ray was shown in the credits of the BBC film Walking with Dinosaurs 3D. National Geographic would once again showcase Nanotyrannus just 2 years later in the 2015 documentary Dino Deathmatch, which revolves around the revolutionary dueling dinosaurs discovery. 2 additional appearances of Nanotyrannus both take place in 2020 as its latest documentary appearances. The first of which was in Dinodana the movie, where it is subsequently referred to as a T-Rex, along with the controversial Discovery Channel docuseries Dino Hunters. In Dino Hunters in particular, Nanotyrannus is incorrectly referred to as Nanotyrannosaur. Additionally, in 2011, the Discovery Channel documentary Dinosaur Revolution, in the final episode of the series Endgame, would feature a juvenile Tyrannosaurus Rex named Junior, whose skull features, upon inspection, have 16 to 17 teeth in one of its maxillae. This is notable as this is the tooth count that represents a Nanotyrannus individual as stated by the recent Dueling Dinosaurs paper, meaning the model in Dinosaur Revolution, while stated to be a juvenile Rex, is actually a model of Nanotyrannus. Overall, while Nanotyrannus may not have as much of an in-depth retinue of pop culture depictions as its more famous Tyrant cousin, this is largely due to its prior relegation to synonymy with said Tyrant Lizard King. However, now that it is definitely known to be its own separate genus, it is likely that we will soon see a great many dedicated documentaries that delve deeper into this animal in its natural environment. Yet, while we still have a lot to learn about this animal, there is only so much that can be ascertained from the rocks and fossil bones that are left with us today, as, like with all other non-avian dinosaurs of the late Cretaceous, Nanotyrannus would become yet another victim of one of the most violent extinction events that our planet has ever known. Living in the Maastrichtian stage of the late Cretaceous, Nanotyrannus, and indeed all other dinosaurs alive that time, would have been unfortunate victims of the KPG mass extinction event. This extinction event, the second deadliest in the history of life on Earth, would see an asteroid 10 kilometers in diameter slam into what is now Mexico's Yucatan Peninsula, with the force of over 10 million Hiroshima atomic bombs. The resulting impact would send violent shockwaves of earth and water all across the globe in the form of massive earthquakes and tsunamis, as well as raining a firestorm of impact debris down across the planet, incinerating all different types of ecosystems and life. In the wake of this impact event, a massive dust cloud would envelop the entire planet for a period of 10 to 15 years, blocking out sunlight and leading to a complete collapse of the planetary biosphere. The first organisms to die out would be the plants, who, having relied on the light from the sun to photosynthesize, would quickly die off. And, following the death of the plants, herbivores would begin to starve to death without anything to eat. For a time, the carnivores would be fine, as they would persist off the numerous dead herbivore carcasses left lying on the earth. But soon, these too would run out, and the giant carnivores such as Tyrannosaurus Rex would also starve to death. Nanotyrannus, as a medium-sized predator, would be next, and would, as with Tyrannosaurus, succumb to starvation due to a lack of food. And within a decade, this animal, as well as 75% of all life on Earth, would go extinct and be lost to the sands of time forever.
Nanotyrannus lancensis is real. Nanotyrannus lancensis lives.
However, even in death, the legacy of Nanotyrannus lives on in the fossils it left for us to uncover and study. Each new discovery brings us closer to understanding the true nature of late Cretaceous North America and the ecosystems that called it home. And indeed, Nanotyrannus specifically sheds light on a new reality. A reality that the diversity of dinosaurs was not in decline before the asteroid hit, but rather was flourishing just as it was throughout any other time during the Mesozoic era. And, more importantly, Nanotyrannus also sheds light on the discoveries we still need to make, such as the true nature of Tyrannosaurus rex growth from hatchling to adult, and those discoveries regarding the mysterious eastern continent of Appalachia that Nanotyrannus' kind may have originated from. A continent filled with old tyrannosaurs not closely related to those that we know from the dynasty of Tyrannosaurus rex, but rather those more closely related to animals it competed with in Hell Creek, such as Nanotyrannus, the Dwarf Tyrant. Thank you all for watching our video about the infamous, one and only Nanotyrannus. This dinosaur coming to light once again was certainly a surprise to us all, and we just couldn't help but having a blast during its production. We hope you all enjoyed this video as much as we did making it. This video was directed by the Primal Earth, narrated by myself, SpinoDragon145. It was written by the Primal Earth, CrimsonAcro, and myself. The video was edited by CrimsonAcro, the Primal Earth, LegitEliminator, Straight Up Murph, and myself. The graphic designers for this video were Straight Up Murph for the creature designs, TheDinosaurHunter for the thumbnail, along with Enlatheus' model and animation, and Mephilas Seijin101 for the Juvenile Rex and Enlancensis model and animation. And the researchers for this video were CrimsonAcro, the Primal Earth, and myself. Additionally, if you would like to support our channel, consider becoming a member of Patreon. Patreon members get their names credited at the end of each video, get early access to new videos 24 hours before release, and even get to vote on new videos. If you'd like to support this channel in another way, make sure to share our videos online wherever you can. Sharing our videos is the best way to help the channel grow in size and expand to new audiences. With that said, thank you for watching, and we can't wait to see you in the next video.